Okay, graphing reciprocal functions. We are going to graph this function, reciprocal of a quadratic function, just thinking about the characteristics rather than working through a table of values like we did previously. So the key is we want to just quickly talk about these characteristics. Okay, your x-intercepts of your original function is going to represent your non-permissive values of your reciprocal function. Behaviors near your non-permissive values, your y values will approach positive or negative infinity. Your y values will approach 0 at your end behaviors. So as your graph approaches the horizontal asymptote, your y values will approach 0. Okay, your domain and range should be all real numbers except for your non-permissive values. Your range should be all real numbers except for always y cannot equal 0. Your vertical asymptotes will represent the non-permissive values or the x-intercepts of your original function. Okay, the equation of the horizontal asymptote will always be y equals 0, which occurs at your x-axis, and then your invariant points will always occur when y is plus or minus 1. Okay, so how do we talk about that, or how do we use this information to sketch a graph? Okay. So what we're going to do is we're going to take our original function of x squared minus x minus 2, and the first thing we want to find on this original function is the x-intercepts. So my x-intercept is when our y value is 0, so I'm going to substitute 0 for y and solve for x. So this can be factored nicely, and my x-intercepts are going to occur at 2 and a negative 1. So I'm going to just quickly sketch this graph very lightly on my graph. Okay. The next thing I want to quickly find is the vertex, get an idea of where the vertex occurs, and remember, quick find of our vertex is a negative b divided by 2a. So this is going to be a positive 1 divided by 2 times 1, which is 1/2. And then I'm going to substitute in that value for x to find my y value. And my y value works out to be negative 2.25. So my vertex is going to occur at 1/2 and negative 2.25, which is approximately here. Okay, so I know this is a parabola that opens up. My y-intercept also occurs at negative 2, so I'm just going to lightly sketch. That point. Here's my vertex, here's my x-intercepts. I'm going to just lightly, with a pencil, get a sketch of this graph. Okay, so now we're ready to, now that we have a sketch of my original function, now I'm going to sketch my reciprocal function. So the key to your reciprocal function is first to identify all of your asymptotes. Well, my vertical asymptotes are going to occur at the x-intercepts, which are here, and at x equals positive 2. So x equals negative 1 and x equals a positive 2. I'm also going to have a horizontal asymptote at the x-axis, always. So always, 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 there's a horizontal asymptote at y equals 0. Okay, so there are my asymptotes. All right, so now I want to identify my invariant points. Well, if I look at my graph, your invariant points will always occur when your y value is 1, so approximately here, here, negative 1, and negative 1. So we have 4 invariant points. Invariant points, again, are points that do not change after the transformation. So if I want to find those invariant points, more specifically, I am going to substitute in a positive 1 into my y value and solve for x. This is going to be a minus 3. So when I substitute this value into quadratic formula, because it cannot be factored, I'm going to get the following. So x is equal to 1 plus or minus root 13 all divided by 2. Well, if you were to evaluate this to get an approximation, we get approximately 2.3 and -1.3. So if I were to plot those points, my x value is 2.3 and 1, so this is one invariant point. And my other invariant point here is here, which is at approximately -1.3 and 1. Now I want to find these invariant points, so my invariant points here is my y value is a -1. Substitute that in and solve for x. Again, this cannot be factored, so I have to use quadratic formula. And this is going to simplify to 1 plus or minus √5 all divided by 2, which again is approximately 1.6 and -0.6. So at -0.6 and -1, this is another invariant point. So now I'm going to plot this point. And I'm also going to identify this point is 1.6 and -1. All right, so now I'm ready to actually sketch this graph. This is where it gets a little bit tricky. If you can visualize all of these, we're going to break this up into basically 3 sections. 1, 2, 3 sections that are separated by our absolute value signs. So technically what you want to consider is all the values above and below these invariant points. Well, all these values above the invariant points are whole number values that are approaching infinity. When I reciprocate this, these values are going to get smaller. So anything that approaches infinity in your original function is going to approach 0 of your new function. And vice versa for this little piece. All these values that are smaller than 1, when you reciprocate that, they are going to get larger than 1. Or these values that are getting closer to 0 this direction will now approach infinity. So this branch of our original quadratic is now going to look like this. And I do not want to cross over that asymptote. So this branch is now becoming this branch that's approaching 0. This little section should now be approaching infinity. Okay, same thing with this portion of our graph. Technically, this vertex at -2.25, when you reciprocate that, becomes -0.44 approximately. So this vertex is now here. Okay, this y-intercept of -2 should now be -1/2. Here's my invariant point. So you can start to see the shape taking place. This little value, these little values in here should now approach -infinity. So this is going to approach your asymptotes on either side. We're just going to create a little curve here and then approach this asymptote here. Okay. And then this branch is going to do basically the same as what this branch did. This little section here that is between 0 and 1, when I reciprocate that, that's going to become a very large value. And this branch, when I reciprocate all of these values, right, like this y value of 2 becomes 1/2. This y value of 3 becomes 1/3. 4 becomes 1/4. 5 becomes 1/5, and so on. So all of these values that are approaching infinity are now going to approach 0. So this branch is going to look similar to our other one on the other side, where it's approaching both of our asymptotes. We're going to attach arrows to the end of them. And that is how you graph a reciprocal function.